Hello and welcome. Took a bit longer than expected, but apparently this stuff is quite hard. I'm Berard, this is my database connection. Let me show you how I've done it. I want to start off with that this episode was nearly finished a little while ago. The problem was what you see on screen right now, timeout errors between the Arduino and the database. I figured out it would be an issue for future me and made the episode anyway, since intermittently the code worked, so I knew the Arduino programming was right. However, future me caught up before I could upload. If you want to hear me rant about the cause for a bit, stick around. But if I manage to figure out how YouTube chapters work, you can use those to skip this or find a specific point in the video you're looking for. Basically, I made this. The location of the arrow indicates if something is pulling or pushing data. We already got the Arduino to pull measurements from the sensors. Now we need to push that data to a database so that the web output can pull the data from this database. For the database and the web output I used XAMPP. There's multiple options available, but these caught my eyes because they're very easy to set up. But this is where my issue lies. You see, XAMPP has a MySQL database built in. Perfect, I thought, because there's a MySQL plugin for Arduino. What I did not know is that there are 3 different MySQL branches. A while ago, MySQL split in 2, and now you have MariaDB, which is open source and is the variant that XAMPP uses. The Arduino plugin, however, is written for the other branch, which is the one by Oracle. And Oracle also has a split between their free version called MySQL and their enterprise variant. Running the MariaDB version gave me issues, and the enterprise variant is massive overkill for what I'm trying to do, so I now chose MySQL by Oracle. I used the MySQL installer to get the database on my PC. This allows for a quick install of the database and additional software we need. Personally, I installed everything, so I would have everything I could need. If you want to be more selective, you'll need at least the database and the workbench. The workbench is your interface with your database, but more on that later. The install is pretty straightforward. My only struggle was changing the default save location. If you're like me and don't want a database on your C drive, make sure to check the options everywhere. Since everything is already running, as I had to check if this solved my issue I mentioned earlier, I can't show you exactly what I've done. Only note I can add is that I added an admin user account when prompted to add accounts. Not quite sure if it was needed, but I figured it could be useful. We'll add the other accounts we need later via the workbench. When you have the database running and the workbench installed, open the workbench and your screen should look like mine. Under MySQL connections, you can see the database running. Click the gray tile with the local instance. You're now inside the database. On the left, you can see I have 4 schemes already. Might be butchering the pronunciation of the word scheme here, but you know what I mean. 3 are examples that were put here by the installer. The top one I already made, but let me run you through the steps on how I did that. Add a new scheme with the button here. Give it a nice name, leave the other settings as is. We have no real reason to change these. When happy with the name, click apply in the bottom right of the screen and apply after reviewing the SQL script, which should just say create scheme with your scheme name. Your scheme is now listed on the left of your screen. Double click it to open it. The tables row doesn't have an arrow yet like mine does here. Let's change that. Create a table with this button and you'll end up with this screen. Give the table a name. I used live_measurements and add the columns. You'll add a column by double clicking in a new row. In this case, just below the column name. The columns I made before look like this. The room name is a varchar of max 255 characters and is not nullable. That means it has to have a value. The measurements are 5 by 2 decimals that are nullable. The 5 means there's a total of 5 digits. The 2 means that 2 of these digits are behind the comma, leaving 3 in front, which might be slight overkill for temperature, but a humidity of 100% is possible. Nullable is required here because if a sensor is broken or not properly connected, it will output null, and I want that in the database so I can see if something's wrong. A quick sneak peek, with working Arduino code, the table now looks like this. That is seal of approval worthy, even though it's quite cold here. One thing left, adding a user. In the window, top left, click Administration, and then Users and Privileges. Click Add Account in the bottom, and a new user account will appear. Give this account a name and a password. You'll need the password when programming the Arduino, so remember it or write it down. Now go to Scheme Privileges. Use the Add Entry button on the right. Use Selected Scheme and select the scheme you made. Now mark all object rights on the left. Your Arduino needs these rights in order to interact with the database. Click Apply in the bottom right, and we're done here. And now for the actual coding part. Have the Arduino take the measured data and put it in the MySQL database. We can use the code from last time as a good base, but we'll have to add all the network and database stuff. On screen now are all required code components. I'll keep this list in the top and mark the item we're currently working on in green. That way it's easier to look for something specific later on. To connect the Arduino to the MySQL, we need a conveniently named MySQL connector Arduino by Dr. Charles Bell. I've added to my sources and included additional libraries. My Arduino, the Uno R4 Wi-Fi, supports Wi-Fi, so that's what I'm using. If you're using a different Arduino, you may need to swap out the Wi-Fi S3.h library, either for a different Wi-Fi library or for an Ethernet one. Please note that a different library can result in slight differences in the code, especially if you're using Ethernet. Differences can be found online, but if you're struggling, leave a comment and either another viewer or myself might be able to help. Next in the list are constants and variables. The constants have not changed, but I added 3 variables. The counters are used to track how many attempts are needed before a connection is successful. This is especially useful if there are connection issues, of which I've had plenty. The status is used to check the Wi-Fi status. Last in the preparation stage is preparing some items for the database connection. From top to bottom we have the query preparation. Everything here will be used to send the queries, which are basically database commands. Important are the percentages in the top right. The percentage and letter indicate the type of data that is used. I ran into multiple issues due to wrong data types being used here. The database start contains all info the Arduino needs to connect to the database. These are the server IP address and the username and password for my Arduino account in the database, with some data conveniently censored. If your database is localhost like mine, which means it runs on the PC you're working on now, the IP address of your database is your PC's IP address. You can find that by pressing your Windows key, typing CMD, pressing Enter, and entering ipconfig as one word. Press Enter and you should see all the network information of your PC appear on screen. Something that threw me off at first is that the IP address uses commas instead of dots, so pay attention to that. Below the database is all information about my Wi-Fi connection, censored again for my digital safety. And finally, the Wi-Fi client. To be honest, I don't really know what this does, but it is needed to make the connection a bit further in the code. Void setup has not changed as far as I can remember, so I'm skipping past that into the loop. First, we connect to the Wi-Fi. It will check if the Wi-Fi is connected. When it is, the Wi-Fi counter will be set to 0. If not, it will increase the counter by 1 and print set counter. That's how we know how many attempts have been made. It will then wait a second and retry the connection. As long as the connection has not been made, it will loop here. When a connection has been made, the Wi-Fi information is printed and it leaves the loop resetting the counter. The database connection is very similar. There are two differences. Before it prints the new attempt number, it will make sure the previous connection attempt is stopped using the con.close command. The other difference is obviously the actual connection, since the command is different and the connection command automatically outputs a message with important information. Since the measurements are identical to the previous video, we're skipping straight to the upload of the data. To start off, it makes a so-called cursor. This is used to point to the database, so to say. Next up, until line 146, is a loop which is ran for each room. It will store the temperature and humidity for the room it is uploading into the buffers using DTO strf. This also stores the measurements as string. I have tried to store it as float, since that is its native format, but I ran into issues where the temperature of my room will be in the millions degrees when storing it into the database. Switching it to a string seems to work without downsides, but if you know something I don't, please let me know. The next lines are quite straightforward. The sprintf command takes the queries we prepared at the start of the code and finalizes it with the relevant data. The great serial print command is used for troubleshooting and shows the query before it is executed by the execute command. At the bottom of the loop, it prints which room it just updated. When it has passed through the loop for all rooms, it deletes the cursor to prevent memory leaks. And then, ending on an easy note again, it prints two empty lines with a tilde line in between to clearly show in the log when the main loop has been completed. It will then wait 5 seconds and start the whole process again. Now the monitor looks something like this. Sometimes I do get an error with the database that looks like this. You can see in the right screen how it immediately reconnects and continues, so I'm not too bothered about that. Finally, let me show you how to check your actual database. Open the workbench, select your scheme and right-click your table. Your screen should look roughly like this. Click the top option, select rows. You'll see your current database and the query it used to get this. If you want to refresh, click the lightning symbol and it will rerun the query. And with that, we're at the end. Look at the plans I made in the first episode, we're doing quite well. There are 4 items we can look at now. A web output, so we don't have to dive into the database every time. Storing the measured data, so we can look back. House coverage, since having 3 sensors on my desk isn't helping me much. And a bonus one, which isn't listed here. My Arduino has an LED grid and I would like to use that to show the status, especially if it has connection issues. For the next time I will look into the LED grid, since now I have to open the Arduino monitor to see if everything is working. If you have a preference for what to do after that, let me know. And thank you very much for joining me, and I hope to see you in the next episode.